Okay, students, so this week we're going to talk about the counting principle, fundamental counting principle, that's how it's called. All right, so what it is that you're just multiplying. You have different options, you multiply. Let's see. You can use the counting principle to find the total numbers of outcomes in one activity can occur if one activity can occur in n ways, so any ways, right? N ways, certain ways, and another activity can occur in n ways, then both activities can occur in m times n ways. Okay? All right, let's look at some examples. So, let's look at this one. To leave her office, Karen can choose between 3 sets of stairs and 7 doors. How many ways can she leave her office? Well, you said many ways, right? So if m ways and then another set of ways, then you just multiply. Easy as that. 3 sets, right? And 7. So that's 3 times 7. That is 21 ways she can leave her office. So that's how many ways she can leave her office. All right, let's look at one that we usually have a lot. It's the one with the dinner menu here. A dinner menu consists of 5 appetizers, 12 entrees, and 3 desserts. How many ways can someone order 1 appetizer, 1 entree, and 1 dessert? Well, you're multiplying 5 times 12 times 3. 5 times 12 times 3, which is 180. Okay. Yeah, that's how it is easy here, huh? All right, let's look at this one. So it says, this one says, a day of the week is chosen. So there's 7 days of the week. Then the spinner to the left is spun twice. How many outcomes are possible? So you have 7 days, right? So 7 days times, well, you have how many things here? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12, right? And then, but the spinner is spun twice. So that's times 12 again. So the outcomes should be 1008. Okay. So notice that 7 days times, well, there are 12 spaces here, 12 slices. So that's 12. And then, but it's spun twice. So that's 12 again. Okay. Check out this one. I really like this one. How many ways can someone randomly dial a 7-digit number? Well, a 7-digit number, there are 7 numbers, right? And how many digits are there? It's really from 0 to 9, right? Because 10 is made up of 1 0. So 0 to 9. So that's 10. So that's 10 to the 7th power, which is a million. Just count the zeros, right? 7 zeros. Nice, no? I really like that one. I don't know why. It's like multiplying 10 7 times, right? Okay. All right. Let's see. This one is pretty popular too. A quiz contains 5 multiple choice questions. Each question has 4 answer choices. How many ways can the questions be answered? Well, you have 5 multiple choice questions and 4 choices. So that's really 4 times 4 times 5 times, right? So 4 to the 5th power, which is 1024. So that's 5 multiple choice questions, right? And that each question has 4 answer choices. So that's 4 times 4 times 4 times 4 times, so 5 times, right? So it's, you can just use exponents at this point, right? Here's the multiply. All right, let's look at this combined with probability. Okay. All right. So let's look at this. Let's look at this one. Probability example. So these have, so not only a counting principle, but it also combines it with probability. So a month is chosen at random. Then a standard die is rolled. So there's two things happening here. What is, so month, right? Month is how many months are in a year? That's 12, right? So we know that this is 12, right? It's chosen at random. And die, so how many sides does a standard die has? Well, it has 6, right? So we know those numbers. So what is the probability of getting February? So 1 month, right? This month, then a number less than 5. So a number less than 5. How many are there? Well, let's see. Possible outcomes. Possible outcomes are all the sides in the row in the die and all the months. So that's 12 times 6, which is 72. So that is the possible outcomes. So possible outcomes, right? Now, what is the favorable outcome? So we're talking about favorable outcomes, meaning the probability of getting this one and a number less than 5. So, well, let's see. So 5, we get 1 February, and then we get number 1 in the die, and then another one. Well, we roll it again, and we get February, and we get 2, because notice that it's all the numbers less than 5. So we get February and we get 3, we get February and we get 4, right? Those are the numbers less than 5. In each one you roll, you get February and you get 1, 2, 3, and 4 that are less than 5, right? So that's what? 1, 2, 3, 4. So that's 4 over 72, which is the possible outcomes, the total possible outcomes. And then you have to simplify this. You divide by 4, that's 1 over 18. Simplify the fraction. Okay? All right, so first you got to find the possible outcomes, then find the favorable outcomes. So these are the favorable outcomes. Okay. All right, let's do another one just in case. Let's do this one. Let's see, this one. A standard die is rolled 2 times. What is the probability that it lands on 1 both times? So what are the possible outcomes? So possible outcomes that the die has, yeah, I keep saying the roll. The die has 6 sides each, and it's rolled twice, right? 2 times. So that is 6 times 6, which is 36. We know that. All right. And the favorable outcome is that, well, both times it lands on 1. So that is 2 both times. That's 1 time, that's 2 times. So that's 1 out of 36. Okay. All right. Let's look at this one. A coin toss 3 times. What is the probability of getting heads just once? It's rolled 3 times. So the possible outcome is 2 sides, right? 2 times 2 times 2, which is 8. So that's 2 sides of the coin, 2 sides of the coin times 2 sides of the coin. And then that's the possible outcome. So that's the total possible outcomes. The favorable outcomes are, well, if you roll the coin, I mean, if you toss the coin 3 times, you can get, these are the possibilities. You get H, heads, T, tails, and then THT, right? For tails, heads, and tails. And then the other possible is TTH. You see all the possibilities here that you can get. And how many possible ways are there? That's 3 over 8. Okay, and that's it. All right, I hope this helps.